to this class. So we have a question on the board that says find the x coordinates of the points on the curve y is equal to 2x minus 3 squared x plus 5 cubed, where the gradient is 0. So this question is pretty straightforward. We have to find the x coordinates. We have to find the points on the curve of this given function where the gradient is 0. So the first thing we need to do is to first of all to differentiate this function. So when we differentiate this function, and then at x equal to 0, we can now find the different points from this question. So how do we differentiate is the next question. We are going to use the product rule to differentiate. Why am I using the product rule? Why am I not using quotient rule or any other rule of differentiation? The sole reason why I'm using the product rule is because this is a function of the product of two functions. So whenever two functions are the product of each other, we use the product rule. So in this case, we can see that this function is u and this is v. So using the product rule states that the y over the x is equal to u, the v over the x, plus v du over the x. This is the formula to use for a product rule. Okay, now let's go on with this. We already know what our u from this. We already know what our u is. We already know what our v is, which is what we have here. But we don't know what the v over the x is, and we don't know what du over the x is. So to find du over the x simply is asking you to differentiate, the v over the x is simply asking you to differentiate v with respect to x. And u over the x is saying differentiate u with respect to x. Okay, let's do that. Let's differentiate all of that. So to differentiate u with respect, let's differentiate v with respect to x. So I will say the v over the x is equal to, now I'm differentiating v with respect to x. So if I differentiate that, I'm going to have, okay, let me put this first by saying v is equal to x plus 5 cubed. Therefore, the v over the x will be equal to 3x plus 5 squared multiplied by 1. Now, if you don't know how I differentiated this, let me just run a quick down, just for those who might not really know how I differentiated that. Okay, he never wanted to make this video long, but I think it's best it's long and everyone catches up with my explanation. So v is equal to x plus 5 cubed. Now, this function here, we can say we have an outer function and an inner function. An outer function, let's say that v is equal to, let's say this is u cubed, y is equal to u cubed. So we can now say that dy over du, let's call that y is equal to this. So dy over du is equal to 3u squared. If we differentiate u cubed, we have 3u squared. How did I get 3u squared? X raised to the power of n is equal to nxn minus 1. It's a rule. So whenever I have a function to the power, use the power to multiply the function and then subtract 1 from the power. That's just what I've done. So this is the power, this is our n, this is our x, this is our n. So it's going to be n times u times x, which is 3 times u, then raised to the power of 2. Okay. let's keep that aside. We can also say that the inner function, this is for outer function. And let's say for the inner function, we can say the inner function is, we can call this inner function x plus 5. So if we differentiate x plus 5, that's going to give us 1. When you differentiate x, you have 1. When you differentiate a constant, you have 0. So this will be 1 plus 0. Differentiating 5, which is a constant, you have 0. So 1 plus 0 is 1. So when you differentiate x plus 5, you're just going to have 1. Okay, so now we cannot say that this is the v over the x here will now be equal to 3u squared multiplied by 1. So what we got here, using it to multiply what we got here. Then recall that u has a certain value. So this now gives you that this is equal to 3 into, remember our u was what? Our u was x plus 5. That was what our u was. X plus 5 is substitute. We're just substituting. All squared multiplied by 1. So that was how I got this. You grab? Alright, so let's quickly move ahead to solving this question. Pretty simple and straightforward. You can pause the video or you can rewind the video and look at that again if you didn't understand how we arrived at that. Okay, so where are we? Okay, now we know what the v over the x is. The next thing we want to find is our du over the x. So to find du over the x, let's say u is equal to 2x minus 3 all squared. Therefore, our du over the x will be equal to the same approach I used, what I just solved now to show you how I got dv over the x is the same thing I'm going to do to get du over the x. That's going to give us 2 into 2x minus 3 raised to the power of 1 all into 2. Okay, we are progressing. So now we already have everything now. We have what our v is. We now know what our v is. We know what our u is. We know what our dv dx is. We know what our du dx is. So we just plug it into this formula. So if we plug that in, this is going to give us that dy dx is equal to our u is 2x minus 3 all squared. So what's our dv dx? Dv dx is 3 into x plus 5 all squared. Now I don't need to put the 1 because this 1 is multiplying all of that, so I'll be left with this. Plus, what's our v? Our v is x plus 5 cubed. And what's our du dx? Our du dx is 2 into 2x minus 3 multiplied by 2. Interesting. Okay, so let's move forward to look at the next step, what we're going to do next. Looking at this, I can find some constants. I can bring those constants out. So you can see I can find some constants here. I can just factorize this. By factorizing this, I can rewrite this to say dy over the x. Let me call this equation 1. Let me mark my equations. This is equal to, I can rewrite this. Okay, so I can rewrite this by saying 3 into 2x minus 3 all squared into x plus 5 all squared plus 2 times 2, these are constants, it's going to give me 4 into x plus 5 cubed, and then have 2x minus 3. Alright, we're progressing. The next thing I need to do, I can now factorize this. If I factorize this equation, I'm going to still have the y over the x is equal to 2x minus 3 x plus 5 squared. Now factorizing this, what I'm just doing is I look at this side, I call this my left side, I can call this my right side. So looking at this two, so I'm factorizing this. I want to look at what's common on both sides. So I can see that what's common here is 2x minus 3 on this other left side, and on this right side 2x minus 3 is also common. I can see both of that. Well, you will say on the left side 2x minus 3 square is common. But why am I just taking 2x minus 3? It's because in 2x minus 3 I have 2x minus 3 raised to the power of 1, 2x minus 3 raised to the power of 1. And on this side, I have the same, just 2x minus 3 raised to the power of 1. So because I have this guy, I'm having something here that looks like one of these guys, so I'm just taking one of it out. So that's what I have here. The same thing I'm doing for x plus 5 square. For x plus 5 square, you can see that on this left side, I have x plus 5 squared, which is the same thing as saying x plus 5 raised to the power of 1. And you also have x plus 5 raised to the power of 1. And on this right side, I have x plus 5 cubed. So x plus 5 cubed simply means x plus 5 square, x plus 5, 1. So you can now see that on this side, I have this and this are common, they look alike, so that's why I'm taking x plus 5 square, and I'll be left with only this guy. So this guy will be left, so I have taken x plus 5 square out and leave the rest. We'll come back to the rest. So that's just how I'm factorizing this. Okay, so you just look at what's common, pick what's common from both sides and leave the rest and come back to it. So the next thing I'm going to do is, okay, so picking that out, I'm now left with 3 into 2x minus 3. I'm left with 3 into 2x minus 3. Remember, I just picked out only 1. Plus 4 into x plus 5. Let's call this equation 2. Let's call this equation 3. Now, if you don't understand how I factorize this, it's pretty simple. You just need to look at it again. For factorizing this, I look at this side, I look at what's common here, I look at what's common here, so I can see that I just have 2x minus 3 that is common, so I pick it out, and then I look at this side, what's common, sorry. So I look at this side, what's common, and I look at this other side, what's common. So I can see that what's common there is x plus 5 square. I bring it out. So the rest, I'm rewriting it out. So the next step I need to do is to open this bracket. So this is going to give me 2x minus 3x plus 5 squared. 3 times 2x is 6x. 3 times minus 3, that's minus 9. Plus 4 times x is 4x. Plus 4 times 5 is 20. You can call this equation 4. Okay, moving forward, the y over the x is equal to 2x minus 3x plus 5 squared. 6x plus 4x, that's going to give me 10x. Minus 9 plus 20, that's going to give me minus 11. And I call this equation 5. Okay, so getting to this point, this now becomes our final answer when we differentiate that function. But we're not just asked to differentiate that function, we're asked to do what? To find the x coordinates of the points, the coordinates of the points on the curve of that function when the gradient is 0. That's when x is equal to 0. Therefore, dy over the x when x is equal to 0 given this function when 2x minus 3x plus 5 square into 10x minus 11 is equal to 0. So this simply means that when x is equal to 0, 2x minus 3 will be equal to 0. So that simply means that x is equal to 3 over 2. So when x plus 5 is equal to 0, x is equal to minus 5. When 10x minus 11 is equal to 0, x is equal to minus 11 over 10, which will give you minus 1.1. So therefore, the x coordinates of the points on the curve is given by x is equal to 3 over 2 minus is equal to minus 5, and then x3 is equal to minus 1.1. So this becomes the coordinates of the points on the curve of that given function. Thank you for watching. If you have any question or any part you don't understand, you can feel free to ask me questions in the comment section, and you can also rewind this video to go back to the parts where you don't understand and rewatch it. When you rewatch it, you're going to understand it clearer and better. And if you still don't understand, feel free to point it out in the comment section, and I will explain it again for you. Thank you for watching, and look out for my next video. We're still trading differentiation, and watch out for the next video and more questions we're going to be solving. And also learn to practice these questions. Get textbooks that has these topics and watch this solve questions. Watch other YouTube videos, solve questions from textbooks, expand your knowledge. That's the best way you're going to learn mathematics. Solve it every day. That's just a trick to being a good mathematician. Thank you, and bye for now.